For the last practice, the final project, automated systems with the digitization. We're going to present this practice from the team that is confirmed by Pedro Contreras, Francisco, Ari Hernandez, Jose Gonzalez, and Alex Sanchez. First, how do the double effect piston and valve in three-way two position works? Well, a three and three to half valve has three ports and two positions. The two position refers to two different working positions, on and off one. Of the pneumatic solenoid valve core. The valve core controls different gases passage. When the valve gains and loses power, the pneumatic valve body has three ports, IA, A, and P, and T, of the which P is for E intel and two A and T are for outlet. One of the outlets is normally open and the others are made closed. A string and valves can be divided into normal closed and normal open modes. A 3.5 valve is usually used together with a single action pneumatic actuator and a double single electric control, namely single coil. In the same fact, we need to know how does the ultrasonic sensor works and what kind of materials or range can be detected. First, the ultrasonic sensor has a ceramic transistor that vibrates when electrical energy is supplied to it. The vibration compresses and expands air molecules in waves that travel from the sensor phase to a target object. The ultrasonic sensor measures distance by emitting a sound wave that when the listening or the setter alarm for the echo of the sound wave bouncing for its target before retransmitted. The ultrasonic sensors often offer advantage when sensing clear objects, liquid levels, or highly reflective or metallic surface. The ultrasonic sensor also function well in wet environments, whereas an optical beam may attract ultraviolet surface.
How does the touch sensor work and what kind of materials and branch can be detected? The panel optical touch buttons, ODB, are touch-activated photoelectric switches that replace capacitive touch switches and mechanical touch buttons. The touch output is activated when a finger interrupts its infrared sensing beam without requiring any physical pressure. It had less indicators for power on and output activated. Two-hand control is an operator actuated control that starts a matching cycle by synchronous actuation of both buttons within 500 milliseconds during the hazardous portion of the cycle. If one or both buttons are released, an immediate stop command is used to the matching control. What is edge computing? Edge computing is the extreme case of local computing or processing. The sensor device or device that is coordinating the data has the capacity to process and store it in real time and launch a response if it's necessary. In edge computing, data is processed on the device or sensor itself without being transferred anywhere.
What is cloud computing? Cloud computing is a set of technologies that allow remote access to software, file storage, and data processing, usually over the internet. We can visualize it as a remote server to which we are sending the data generated by our processes, and that data can be processed on those servers using software or artificial intelligence algorithms.
The fog computing can be defined as a cloud technology by which the data generated by device and process is not uploaded directly to the cloud, but is the first prepared in smaller, closer, decentralized data centers. We're talking about fog nodes, pre-cloud processing nodes that act as a mediator between the cloud and the different cloud devices, sensors, machines, and robots. We can consider it as a local network with lower latency than a cloud network, designed to act immediately and quickly. How does the Ethernet network and the PLC logo and Node-RED work? Where the first thing that you need to install is the CMOS library in the Node-RED, and in the SCTE block, it is necessary to add the IP that the PLC has and the variables you have to add to the inputs or the outputs of the PLC that you want to control through Node-RED. Does the node monitor and control the physical device via dashboard, where in this case we put the setting blocks to know which was the input or the output that we wanted to control, and we connect it to a couch block so that we could observe the state in which the sensor or the actuator was, and so that in the gauge we could not true or false separate, but rather we wanted a 1 or 0. We put the switch and change blocks in the middle to change these values.
So now let's talk about Node-RED and how it functions. Well, first of all, we have three main parts of how the Node-RED is organized. First of all is the control part. Then we have the input part, and then we have the output part. As you can see in the Node-RED in the dashboards, we can see them clearly. First the controls, then the inputs, then the outputs. So how do they work? Basically, the control part is a safe state that you can control from the node-RED in order to activate or deactivate a system. So for example, if we don't have the ultrasonic sensor on a true switch, it won't work. Or if we don't have this switch activated in the motor, it won't work either. So we just connected the switches to a TIA portal output. I'm sorry, we just connected, yeah, to a memory.
Okay, now we are going to see the program in TIA portal. It's very simple. As first step, we implement memory elements that are controlled via node-RED. By activating the switches in node-RED, the memory elements are triggered, allowing the program to operate. Next, we have the inputs linked to the sensors, the ultrasonic sensor and the two up-to-touch sensors. The ultrasonic sensor controls the LED, while the up-to-touch sensor are associated with the piston. Both up-to-touch sensor must be activated to send the output signal that triggers the piston, while these sensors are not activated, the output to extract the piston remains active. Finally, for the motor control part, we activated node-RED. And finally, this is the signal for activate the motor, the output of the motor.
We will see a video of how the system works overall. Well, as a conclusion, I can say two main important things. First of all, is to always read the datasheet because for a moment we thought we blew up one of the sensors and one of the actuators because it wasn't working. We spent like 2 days trying to make it work, but it was only until we read correctly the datasheet is that we could make it work. And second one is how to use Node-RED. Node-RED is a really good software that can function as an HMI using dashboards and can save a lot of data and also show us what is happening in the system in a more integrated way. So I really liked this practice. I think I can now use a PLC and how it works as a whole. And I feel prepared to build anything they want me to using a PLC.
Perfect integration of all mechatronic industrial technical aspects that are currently used. I feel delighted with the topics in about all this perspective of knowing data sheets, knowing how a sensor works and how to connect it, creating a cell from scratch as well as the color code on cables and output areas, power inputs among others, folder. But above all, being able to communicate this entire program through a PLC and at the same time manage it and see the interactions from the dashboard. I feel that this practice is a good skill that as a mechatronic I should know, but more than anything understand and know how to do it efficiently. Everything, this was a little new, but the idea is to keep trying until you understand it.
Finally, my conclusion or what did I learn in this project is during the development of this project, I first understood and established the correct connection for the ultrasonic sensor, the opto touch sensor, and the motor. Subsequently, using the software TIA portal, we programmed a layered logic sequence to control the LED behavior via the ultrasonic sensor, the pneumatic piston via the opto-touch sensor, and finally the motor via NORED. So finally, throughout the dashboard in NORED, we managed to control all the sensors and visualize the real-time system status effectively. Thank you.
Well, in my conclusion, during this project, I learned how the PLC works with the TIA portal program, where I was able to observe how the sensors have to be connected for the different actuators to work. I also learned how the board works to connect the entire system. Finally, I was able to learn how the network works and how it can help us to keep all the sensors and networks connected so that we can control them all in the same place and in an easier way. Since the node gives us a dashboard where we can control the sensors by activating or disactivating a switch directly from the computer.
Reflecting on my recent experiences, I have gained a deeper understanding of two critical aspects in the field of electrical engineering and automation. Firstly, I have come to appreciate the vital importance of meticulous reading and comprehensive body attitudes of the instruments when setting up in an electrical cabinet and a PLC system. This attention to detail is essential to prevent potential issues such as short circuits, which could lead to significant damage to the company's industrial repairs. But ensuring that all specifications and requirements are carefully followed, the reliability and longevity of the systems are greatly changed.